All right. So the substitution method is also called the change of variable method. And again, now we're going to start using use, and that's usually what I use. Or you could use a wise or whatever, but you're changing one variable for another variable. So now we're going to replace u, replacing the variable x in our process. So if we substitute u for f of x and du is f prime of x dx, then we get the following things. So for the first one, we had u to the m du. Well, that's going to be u to the n plus 1 over n plus 1 plus c, n can't equal -1 again. Here, if we have integral of e to the u du, well, that just is e to the u plus c. And 1 over u du is going to be the ln of the absolute value of u plus c. Now, again, these are only valid if u is an independent variable or u is a function of another variable and du is a differentiable of u with respect to that variable. All right, so how to integrate by substitution? First of all, you have to select a substitution that appears to simplify the integrand. So you don't want to make it more complicated, and so what you want to do really is you want to make it simpler, and so that's going to be our first case to do. And so basically we're going to select u so that du is a factor in the integrand. Then two, we're going to express the integrand entirely in terms of u and du. So we're going to completely eliminate the original variable and its differential. So if it's x, we're getting rid of, there's not going to be any x's left. Then we're going to evaluate the new integral, if possible, and then we're going to express the antiderivative found in step 3 in terms of the original variable. So once we get it done here, we back substitute whatever the u was and put all the x's back in, or the y's, or whatever it is, and we get to our final value that way. All right, so here we're going to use substitution to find each indefinite integral. So first one says, take the indefinite integral of 2x cubed minus 3, the quantity to the fourth power, times 6x squared dx. And the second one, we're using e. So the first one, let's think about this. Well, if we let u equal that part, how we're going to write this is we're going to say a, let u equal 2x cubed, then minus 3. And then, well, we just find what du is. Well, that's going to be what? Well, that's going to be a 6x squared dx. All right. Now, does this fit with what we have? Well, that will get rid of all the x's here. This piece will get rid of all the x's here. All we're going to be left with is the integral of u to the fourth du. Okay. So that's easy enough, all in terms of u. So that's going to be u to the fifth over 5 plus c. Now is when we do the back substitution, we plug that back in here. So now we have a 2x to the third minus 3. Now it's all to the power of 5 divided by 5 plus c. Okay, what about this one? Well, in this case, I think I'm going to let my inner term be that. And so then I'm going to let, so this is b, so I'm going to let u equal 5w. And so du equals 5 dw. Okay, now we're using w, so this isn't going to be x's, this is going to be w's. Now this is what this is, and the 5 will make that end up being e to the u du. Well, we know how to take that. That's going to be e to the u plus c. Now again, we're going to substitute back in here, so that's going to be e to the 5w plus c, and that's going to be my answer, kind of like that was my answer there. Okay, so not too complicated and gets us to the answer we need, but it makes it a lot nicer. So we have something really nice to look at to do the integration with. Whereas with that, looking at that, everybody would probably start saying, okay, I don't know what to do. Sometimes you'd say, oh, I want to multiply it, but then you'd have to do this 4 times, and then after that multiply that times it all, and then that would make a really long thing, but it ends up being something simple when you do it this way with the substitution. All right, so let's stop there and come back for more.